Welcome to Data Engineers Lunch, a weekly investigation into all things data engineering. Don't forget to like and subscribe, as well as turn on the notification bell so that you can get notified every time we post a video or go live. If you are interested in joining, today's topic is the ins and outs of Data Lakehouse Versioning, the file, table, and catalog level. Thanks to Alex Merced with Dremio for being here to present. If you are interested in joining Rahul and I as co-organizers for this event, want to help find speakers, or speak yourself at this event or our sister lunch, Cassandra Lunch, drop me an email. It's listed here. We are part of a larger community called Data Community DC, which believes in building an inclusive environment. So no matter your race, gender, or sexual orientation, everyone is welcome, and we expect respect to be given to all. Data Community DC is actually made up of a lot of different groups, generally centered around data, and you can find out more about all these different groups at datacommunitydc.org. At Data Engineers Lunch, we cover everything that speaks, eats, or breathes data engineering, from data ingest to data processing to exploiting your data. Check in to our channel for our regular videos. And as always, don't forget to like and subscribe, hit that notification bell so you can stay connected to our content and be notified when we go live. This is a community, so please share your questions in a respectful and courteous manner. I will be monitoring the YouTube chat, so please post your questions there, and I will pass them along to Alex. Here at Anant, we design, build, and manage global real-time data and analytics platforms, especially surrounding Cassandra, Spark, and Kafka. Data engineering is our bread and butter. Thanks to our program sponsors. Thanks to our organizational sponsors, especially GW University, for providing in-person meeting spaces. If anyone has any job offers, you're looking for a job, post a link in the YouTube chat. If you have meetups, hackathons, classes, or conferences you would like to promote, please post those links as well. We currently host Data Engineers Lunch almost every Monday at noon Eastern. Our sister lunch, Cassandra Lunch, takes place on Thursdays. Check out our runbook. This runbook will only be available for a limited time. And all of our videos are available on YouTube. So thank you everyone for being here. Alex is about to share and get started. As always, let's be respectful. And Alex, thank you so much for being here.
Thank you so much. And hey, everybody, welcome back. I'm glad to be here again for another Anand's Data Engineering Lunch. Thank you. And then let me just share my screen here and we begin. Okay, hey, everybody, we're gonna be talking about the ins and outs of Data Lakehouse Versioning at the file, table, and catalog level. Bottom line is, for a long time, we've used things like Git for code. Oftentimes data warehouses would have features for isolating environments and doing rollbacks. But what about the data lakehouse? Okay, that's what we're going to be kind of getting at today. How can we replicate those practices on the data lakehouse so that way we can take the data lakehouse more closer to being the center of our data world? But before we go there, let me just tell you a little bit about who I am. My name is Alex Merced. I'm a developer advocate at Dremio. I've worked in the data and web spaces for several different companies, such as Crossfield Digital, Campus Guard, General Assembly, and many more. I'm one of the co-authors of the upcoming O'Reilly book, Apache Iceberg, The Definitive Guide, and have spoken at many different events, such as Data Day Texas, which I'll be at again next January, OSACon, P99Conf, Data Council. I'll be at Past Data Summit in a few months. Also, I host several podcasts, which I'll mention in a bit. And I like to write code. So I've contributed lots of libraries to the Python and JavaScript ecosystems, whether they're databases, web frameworks, all sorts of stuff. I just really enjoy tech and enjoy enabling the possibilities. So as I mentioned, I'm one of the co-authors of the upcoming book, Apache Iceberg, the Definitive Guide. You can get yourself a free early release copy by scanning that QR code right there on the right. We just updated the early release, so it's about 180 pages at the moment. The final book will be more around 300, which will be releasing early next year. Again, scan that QR code in order to get yourself an early copy of that book for free. And again, I mentioned I host several podcasts. First off is Gnarly Data Waves, which is a weekly broadcast that we do at Dremio every Tuesday, generally about data lakehouse topics. So for example, tomorrow we'll be talking about Dremio Arctic, which is based on Project Nessie, which is one of the things I'll talk about today. Select Star from Data Lake is the podcast I do with my counterpart developer advocate in Dremio, Dipankar Mazumdar. And then just Data Nation, which is my solo data podcast, where I just talk about anything that I feel passionate about at the moment. So that's where you can find more about me. But now with our feature presentation, we mentioned the data lakehouse. So in that case, let's first establish again, what is the data lakehouse? So traditionally you would have sort of data lakes and you'd have data warehouses. So essentially what would happen is you'd have all your data sources, your transactional databases, your log data, your IoT data, and not all of that data was structured, and not all of the structured data should be in the warehouse, where you're paying top dollar for that storage, you're paying top dollar for that compute. So what would happen is that you would have a data lake where you could store all the data, structured and unstructured, whether it's in the data warehouse or not. Okay, so it became this big repository, this basic big storage area of all your data, whether in the past it was like a Hadoop cluster, whether nowadays it's oftentimes an object storage, whether it's in the cloud through AWS S3 or Azure Blob Storage, or still on-prem through like using something like Minio. However you do it, the idea is you have this big sort of storage layer. And you could run analytics on it, oftentimes like ad hoc, read-only analytics. But generally the way you interface with the data is as a bunch of files. Okay, so you might have one data set that's stretched out across 1,000 Parquet files. And, with things like Hive, you could kind of treat them like tables, but it still wasn't quite the same experience as you'd have with like a database or a data warehouse, where all these aspects of data management and data organization are kind of abstracted away from you. So that way, all you have to think about is, let me run SQL against the tables in my database or data warehouse. Problem is, any particular database or data warehouse by itself can only evolve so quickly. And the ways we need to use data are growing faster than any of these platforms can. So the idea is we need to have our data kind of in a place where many tools can access it. So we can always use the right tool for the right job. So what we need to do is standardize the way that data sort of exists, so that way many tools can access it. And this is sort of the idea of the data lakehouse. The idea is like, okay, well, we do have a place where the data is accessible by everybody. That's the data lake. So that's our storage layer. But the problem is just pure storage. It's not interacting with it the way we interact with a database or a data warehouse. And this is where things like a table format, like Apache Iceberg, and a catalog, like Nessie will talk about in a little bit, basically create this layer, this abstraction layer, that makes it when you interact with the data, you can do ACID transactions, you can do disaster recovery rollbacks, basically all those things that you would normally expect a data warehouse to do and more now become possible with the data in your data lake, making it behave like a data warehouse, thus a data lakehouse. So it's that table format layer, that metadata layer, that provides the ability to do optimization, to treat your tables treat your data like tables that can be optimized, that can be run SQL, not just read only, but read and write, the whole deal. Okay, so that's when we cross the line from data lake, more of a sort of ad hoc analytics, more read only, not necessarily our center of transformations per se, to a data lakehouse where we're just pretty much doing everything from that data lake storage. Cool. So a really good practice that makes life a lot easier is versioning. Okay. And this is part of like a growing trend known as data as code. Probably you can also consider it under the umbrella of data ops. Okay, but the idea is bringing a lot of these sort of software type practices for like code quality over to the data world for data quality. Okay, so this is like things like CI/CD, versioning, and let's just talk about what versioning does. So what you're doing is that instead of having to duplicate environments, because oftentimes what people will do now is that if they're going to ingest data, they might have like a dev environment, and then they'll duplicate all their files in the dev environment, then make changes to those files. Then they have to swap out. So you still have this extra copy of your files in your production environment, and then you got to swap it out afterwards. So you're creating a lot more storage. It's just a more cumbersome process. But with versioning, what you can do is that every time you make a change to the data, you capture that as like a snapshot, which allows for like disaster recovery so that we can roll back things. But you're also able to do branching so that way if you do want to make changes without affecting your production line, you don't have to duplicate the data. You'd capture those changes on a branch. Okay, you essentially create a different chain of changes. And since those changes are being tracked separately, they don't affect what everybody else is querying on the main branch. And then once you've made all the changes you wanted to make and you've done your quality control checks and all that stuff, you can then merge those changes back into your main branch, allowing all your production data use to now use that integrated data. Other things you can do with versioning is you can tag commits. So let's say you generally want to tag the data as it is at the end of every quarter, so that way you can easily test against the data as it was at the end of each quarter or each month or each week. You can tag individual commits, individual states of the data, so that way you can replicate that data by a name instead of having to say, okay, give me this specific commit. I can be like, give me Q1, and maybe that's what you call the tag. So it just makes it easier to replicate the data so that we can see how the data, how it was, not how it is, for things like auditing, whatnot. So basically brings all these things, but allows you to do this without having to create duplicates of the data. Because we do a lot of this now, but a lot of times it involves making copies upon copies of the data, paying for the storage to create a copy of the data at the end of each quarter, paying for the storage to, again, create those dev environments. Wouldn't it be nice to be able to do all that without duplicating your data? And that's what version is going to allow to happen. On top of being able to isolate changes, okay, so again, we can make those changes on the branch, doesn't affect mainline production queries, so you're not having to run into any inconsistency issues. You're able to run into multi-table transactions, which normally you could do on the data warehouse, but you haven't been able to do on the data lakehouse up until now. Okay, because again, you can go in the branch, make changes to multiple tables, depending on the technology you're using. We'll get into that. Make changes to multiple tables and then merge in all those changes. You can roll back. You can change the data back to an earlier commit where your data was good in case you make a mistake. And you're not having to spend a weekend backfilling data. Okay, reproducibility, again, using tagging to say, hey, I want to query the data specifically at this point. This point is going to be a point that I'm going to be using a lot for testing machine learning algorithms or doing X, Y, and Z. I want to be able to hit that commit over and over again, and I can tag it. And all of this is going to really enable consistency, quality, and data validation. Because again, I can isolate that data on a branch and then run those checks for quality and data validation, and then have to worry that the data is inconsistent to my end users while those checks are running, because that data is not live until I merge it in. So I can run those quality checks with peace of mind. And all this can be automated in a variety of ways. Now, there are different versions. This is another, we have a embarrassment of riches when it comes to the Lakehouse world nowadays, because of the architecture of Lakehouse, where basically you have your lake storage is basically, you have your data lake storage with a metadata layer on top, which is generally a table format like Apache Iceberg. All the tooling around it becomes quite varied. You have a variety of tools you can use. And right now in the world of versioning your Lakehouse, you really have sort of three possible layers. You have catalog level versioning, which we're going to particularly point to right now. The only tool that really does that is Project Nessie, which is a really cool open source project. So, and again, always the nice thing about something being open source is that you have flexibility. Like, using it doesn't necessarily marry you to a particular vendor. You can always also self-deploy, self-maintain if that's something you prefer or is within your regulatory needs. Table level versioning. Okay, this only really exists within Apache Iceberg, where built into the specification, you're able to do branching and tagging. Like all three formats, Delta Lake, Apache Iceberg, Apache Hoodie, do have commits or isolated snapshots. So you can always roll back to the table to a previous commit, but only Iceberg has the ability to create sort of branched changes at a table level. So what you're doing is you're capturing changes at the table level, not at the catalog level. And then you have LakeFS that allows you to do file level versioning. Which in that case, what you're doing is you're capturing snapshots of what files are in your data lake storage, and then basically You're saying, okay, hey, on this new change, we've added these files, remove these files. On the next change, we've added these files, remove these files. So that way you can replicate and have that same sort of isolation, but it's what it's capturing is not the table or the catalog, it's capturing the sort of the makeup of files on your storage. Okay, so we're gonna go through each three of these, talk about the pros and cons. Depending on what your use case is, one or multiple of these might be very appropriate for your particular data lakehouse situation. So the first one we're talking about is Project Nessie. Okay, Project Nessie, which is catalog level versioning. Essentially, the way it works is that it acts like a data catalog. So it's tracking, essentially it becomes the interface for tools to know what is in your data lakehouse. Okay, so right now, Nessie primarily works with Apache Iceberg tables, but the way Nessie works doesn't preclude it from working with other things in the future. Okay, right now, what happens is that the Nessie catalog captures sort of snapshots of the catalog. And the catalog is made up of a bunch of keys, which are really just namespaces. Okay, and then each key has a bundle of metadata with it. So in this case, you might have, table A, that's one key. So and then that's going to have a bundle of metadata saying, okay, hey, here's where the metadata for this table exists. If it's an iceberg table, if it's a namespace, it'll just track the namespace. You can also track iceberg views. So you can actually track views with that. There's a lot of things you can kind of track, but it'll say, okay, here's the key, and here's the information about that key. And then anytime one or more keys change, it creates a commit. And what it does, it creates another snapshot of all the keys and their metadata. Okay, so essentially what happens is that right now we created table A and table B. Okay, but now I want to do some ingestion. So I can create a branch. And what it does is not creating a branch of an individual table, but of the entire catalog. Okay, so I've now created an isolated environment, not just for one table, but for all the things that Nessie's tracking in this particular catalog. So now when I make a change, okay, so we get here to commit to on the branch, notice that table B now is pointing to a different snapshot. So its metadata is now pointing to the updated snapshot after we've ingested data in the table. And now if I want to publish that change back to my main branch, I can then just do a merge, and then that commit now exists on the main branch, and now they are in sync. And the cool thing about Nessie is that any tool that supports Nessie can interact with this sort of abstraction. So this includes Dremio, Spark, Flink, Trino, Presto are all able to interact with Nessie catalogs. So I could create a branch on one tool and make use of that branch on another tool. So basically it allows you to kind of use this abstraction across multiple tools, which is pretty nice. And again, in the future, it has created like support for Delta Lake, but it required like there was a pull request to the Delta Lake project that never got accepted. Nowadays, Delta Lake has changed so much that they probably would have to like update that pull request, but that is something that might exist down the road where Nessie also supports other formats other than Apache Iceberg. But right now you have first class support for Apache Iceberg. Okay, catalog level version with Nessie. So again, basically what it's doing is that it's capturing the catalog. Each commit is not, what it's capturing is not pictures of a single table, but pictures of the state of the catalog. So you can see here, we have tables A, B, and C. And then on this commit, table B got updated. And then on the next commit, we see that table C got updated. And we can kind of see that their snapshot, the snapshot they're referencing is changing. Okay, so just to kind of get an idea of the architecture of Nessie. Now, pros to this approach. Because you're capturing the catalog, you can isolate changes to multiple tables and publish transactions to multiple tables at the same time. So this enables multi-table transactions. Okay, so being able to change multiple tables, but publish them at the same time for consistency. Multi-table tagging. So instead of having to tag each individual table to replicate a particular state of your catalog, you can just tag the whole catalog and be able to replicate every table as it was at that point in time, at the time of the tag. Multi-table rollbacks. If something goes wrong across multiple tables, you don't have to roll back each individual table. You can just roll back the entire catalog in one command, okay? Making disaster recovery really easy. You have branching and merging. A nice thing about Nessie is that everything is very SQL oriented. So all the branching, all the merging, all the tagging, all of it can be done through SQL, okay? So you can do it through SQL. Nessie also has a REST API, so you can interact with it through a REST API, and it does have a Python library. It has a cloud managed service. So basically, you can deploy your own Nessie server, that you use for your data, and you can manage it your own and change the way it handles authentication, where you store the data for Nessie. Like it's very flexible. But if you want to go through all those headaches and you just want to turn on a switch and have a Nessie catalog, you can use Dremio Arctic. Dremio Arctic, what it does is it's a cloud managed services providing you that catalog. It's free, so you get the catalog for free. You just sign up, and essentially you can use that as your interface with your Iceberg tables, and then also track your Iceberg views across different tools. But again, you don't have to set anything up. You just sign up, and then you have the catalog ready to go. And then if you want, then you can also take advantage of a feature in that where it does automatic table optimization. So you get the catalog with the Git-like features, but you can also schedule automatic like compaction and expiring your snapshots. So that way you don't even have to think about maintaining your data lakehouse tables, really giving you that database feel. Okay, because now you have the flexibility of the power of Iceberg. You get the power of those Git-like features, and you don't have to think about the optimization of your tables because it's on automatic. Kind of like when you're using a data warehouse, where you don't generally aren't thinking about what's going under the hood in a data warehouse about how those tables are being maintained. All that's abstracted away. This kind of goes a long way in that direction. It's very lightweight architecture because again, it's not capturing every individual file for every individual table. It's only tracking the location of the metadata for Iceberg tables. So in that case, the amount of stuff the amount of information it has to capture within each commit is very low, which gives it the ability to handle a very high throughput. It's storage agnostic. You can use, at the end of the day, when you're using an Apache Iceberg catalog of any type, it's agnostic to where you store the data. So you can be storing the data on-prem, in the cloud, because all the catalog does is track the location of the metadata, and it's the metadata that actually says, hey, here's where the files exist. So long as the engine can access the catalog and then access the metadata for the catalog has done its job. Okay, and you can use it with all three clouds. Like it's just a service you can deploy on your own. Currently, right now, it's Iceberg tables and views only, and maybe Delta Lake in the future. Who knows? Maybe even Hoodie after that. Like theoretically, when you think about the way it's set up, adding that shouldn't be too difficult because again, it's just literally a key with a bundle of metadata. So it's just figuring out sort of what is the right bundle of metadata to be able to track those particular table types consistently for engines that would need to refer to them. And it's an open source project. So, if you need that kind of support, you can easily make a pull request to add that in or customize it for your own particular needs. It does preclude other Iceberg catalogs. So for those who aren't familiar with how Iceberg works, the way Iceberg works is that a tool interacts with your catalog of Iceberg tables, and that catalog becomes the arbiter of truth of which tables exist and what's their current state, which means you can only really use a catalog for any particular table. So one catalog can track many tables, but that table should not exist in more than one catalog. Okay, so in that case, if you're using Nessie as your catalog, that means any of the other potential Iceberg catalogs, JDBC, AWS Glue, whatnot, those would not be what you use, in a sense. It requires running a service. So if you self-deploy Nessie, you do have to maintain that instance. You have to run a server, maintain it, configure it. But again, if you don't want to do that, you can always use Dremio Arctic and just use the cloud managed service. Now, the second type of versioning is table level commits, table level versioning. Right now, Apache Iceberg is the only of the three table formats that I'm aware of that has table level versioning. Like they all have snapshots, so all of them have individual snapshots that you can roll back to. But Iceberg, built within Iceberg, so it doesn't matter what catalog you use, doesn't matter. It's just something built into every individual table. Is that the table you can create a branch of the individual table's snapshot history. Generally, it works a little bit differently. Instead of just having these like branches that just persist, you do give them an expiration date so that branch will only exist for a period of time, because they're mainly made for like short-term purposes, short-term experimentation, short-term ingestion. So I can create a branch, say, hey, this branch has a 7-day life and holds a maximum of 2 commits at a time. And I can create that, and then again, engines that support that feature of Iceberg will then honor that. You can tag particular commits to the individual table. So you have that flexibility at the table level, but again, each table is different. So if I had like 20 tables and I wanted to tag all 20 of them, I would tag all 20 of them individually. If If I'm doing an ingestion job on all 20, I would branch each of them individually if I'm using this level. Now, pros to this is that you do have single table transactions. So again, you got that transaction consistency across that one table. You can tag an individual table's state. You can roll back the individual table to previous commits. And there's a lot of flexibility with how you do that. Single table branching and merging. So again, you have branching, merging, but again, it's just one table at a time. Some of those operations are via SQL. Like you can create the branch and then switch branches via SQL. But when you want to take those commits and then like merge them back in, that you can't do via SQL currently. So essentially you could create the isolation on a branch, do all that via SQL, but then at the end, you'd probably have to go back into like Java. Right now, I think mainly Java, eventually probably Python to actually do that final pulling that commit into that other branch. So not quite as perfectly SQL all the way. Works with all catalogs. So the nice thing about it is that it's built into the Iceberg spec. So you don't have to use a particular catalog to use this feature. So you don't have to run any particular service. It works based on the way the metadata is tracked. So basically inside the metadata, it's just tracking different chains of snapshots that are all tracked within the snapshot. And then essentially like the reading of that's just done by whatever engine's reading your table at the time. So it doesn't require you to run another service to take advantage of it. So it's something that's always there if you're using Iceberg. It's storage and cloud agnostic because again, Iceberg is going to be, it doesn't matter where your files are stored because it's just as long as the metadata points to where those files are stored. And that can be across any cloud if it is in the cloud. So you have all that. It's Apache Iceberg only. Okay, so Delta Lake and Apache Hoodie, maybe they change their specs to facilitate something similar to this. Right now, basically, as far as like Delta Lake and Apache Hoodie goes, as far as I understand it, they generally all use the third approach I'm going to talk about because it's the only approach that's available for that particular format. One of the nice things about Apache Iceberg is you have choices. And we'll get into that format. There's no multi-table transactions because again, it's only isolating it at an individual table. They are working on a multi-table transaction spec for Iceberg, but it'll still be at the catalog level. So it'll be a spec for catalog implementations. And it'll only handle multi-table transactions. So it won't handle like all the possible use cases you saw with like Nessie, because you're still not capturing catalog level commits. What it'll do is what this multi-table transaction specification that they're working on does is it allows you to kind of do a transaction like you do in a data warehouse where you'd start a transaction and then you would do all your changes and then you would end the transaction and it would commit them all at the same time. But then again, when it comes to like rolling back, it's not going to be as simple as just moving the catalog level commit back because there is no catalog level commits in that spec. So there will be multi-table transactions eventually in the Iceberg spec, but it's going to work a little bit differently than what Nessie does. No multi-table rollbacks. You can't just roll back the catalog. What you can do probably once they have that transaction feature is you'll be able to do like start a transaction and then roll back each table individually within that transaction and then end that transaction and then kind of roll them back all at the same time. But again, not the same sort of form factor. No multi-table tagging. Again, each tag belongs to an individual table. Again, you can do that once they implement that transaction thing. You can always open a transaction, do a bunch of things, close that transaction, but there's no sort of tracking. There's nothing that's tracking sort of all those changes at a higher level. It's just they're just going to allow you to just sit there and say, okay, do a bunch of things and commit them at the same time, similar to what you see in data warehouses. Then there's file level versioning. So this is where like Lakehouse comes in, and what Lakehouse is doing is that it doesn't matter what table format, okay, because it's not looking at metadata. It's not tracking table metadata. It's just tracking the files that they are in your storage. Assuming that generally your files are going to be immutable. Like you're not editing the files. Generally, object storage is immutable files. So like you don't edit things, you replace them. So essentially what it's going to do is that every time you make changes to your storage layer, it captures a commit saying, okay, hey, these files were added, these files were subtracted. So you can see here is like, hey, commit 1, our storage had file A and file B. But as of commit 2, we have A, B, and C. Well, as of commit 3, you can see that B is no longer there, but D is there now. Okay, and I can go back to any of these commits to see my file system as it was at that point in time. Okay, and you can do branching, you can do tagging, you can do all that, except you're doing it based on snapshots of the file system. Okay, which has some pros and cons to it. Okay, because you're doing it on the file level, you can do multi-file transactions. So you could be, again, it doesn't recognize, hey, which files belong to which table. It's just looking at the changes of files. So you could create a branch, and then changes of files are happening across what are equivalently multiple tables, and you still have that sort of multiple table transaction consistency. So you can still kind of do that multi-table transaction, create a branch, make changes to multiple tables, regardless of format, and then merge those changes in. Same thing with tagging and rollbacks. All that stuff can theoretically happen across multiple files, regardless of which data set those files belong to. So you can still do all those things. Works with Delta and Hoodie, and no format with no problem. Okay, so because basically Delta and Hoodie, they generally work purely based on sort of like the file system. So basically, like if I were an engine, you would just tell me, hey, this folder has the table, and then there's a certain sort of file structure to what a Delta and a Hoodie table looks like that's kind of universal, so an engine can just read it. Iceberg's a little bit different because Iceberg detaches itself from a particular file structure. Iceberg actually allows you to have your data files theoretically anywhere, so you can do in-place migrations, which is really cool because you don't have to duplicate your data to migrate to Iceberg. But in that case, like it goes beyond just what's in the file system. Okay, basically, what is the arbiter of what's going on is really the catalog. So LakeFS, what they did do.
Hey, Alex, we've got 2 questions in the chat. Do you want to take them now, or should we wait?
I'll take them. I'll just take them at the end because I might answer them in the next couple slides.
Okay, great. Thank you.
Cool. But LakeFS has created a catalog for Iceberg that allows you to, because basically what happened with Iceberg is that since Iceberg currently in its specification uses absolute file paths, so essentially every individual's file is listed pointing to the specific location that it's at. The way LakeFS works is that the branching is done through the file path. So when you create a branch, you would say, like, main would be in the S3 file path. And then you would say, okay, here's my ETL branch. And then you would have ETL where it would say main in that S3 file path. So the problem is you might make the change from the ETL branch, and then the Iceberg metadata will be written with like ETL hard coded or hard written into the metadata. But then, later on, you're switching the context to main and you're doing that merge. The metadata is still going to be sort of off to what's going on in the file system. So there's consistency issues. So the LakeFS catalog, what it does is that they're working on a dynamic, a relative file path spec for Iceberg, which is not completed and implemented yet, except for in the LakeFS catalog. They took sort of like where it's at now, implemented into their own catalog that you can use for your Iceberg tables. That does factor that in. But basically, if you want to use LakeFS for Iceberg, you have to kind of use their catalog at the moment. We'll see what happens in the future if, when that relative file path spec rolls out. But that's kind of the state of things as far as like Iceberg goes at the moment. Generally, because it's done at the base, it's done through file paths. Essentially, what you do is you're going to go to like sort of LakeFS, you're going to create the branch. And then what you're doing is when you do your operations, you're just specifying that you write the files to the file path for the branch that you're using. So you're not necessarily like using SQL to say, okay, hey, let me switch branches, let me create branches. What you're doing is you're creating a branch, and then just basically when you do transactions, make sure to specify the file path that those transactions occur in, and that sort of designates what branch you're on. It requires an S3 compatible object storage layer. Okay, so you couldn't do this on-prem. So if you're using Hadoop, this would not be an option because it requires that particular way that file pathing exists in the S3 specification. So it only works with S3 compatible file storage. So it's not storage agnostic, even though it is table format agnostic, because you can use that with any format because it's not capturing the format's metadata, but the actual files in the file system. So again, pros and cons to each of these. Like there's going to be situations depending on what your use case is where these will may work or not work. So to kind of summarize this, and then we'll start taking questions shortly after this. Basically, if we take a look at catalog level, we'll actually just go through each of these. So when we look at isolation, so being able to isolate ETL work onto a branch and then be able to publish it, all three offer you a way of doing this. So again, with catalog, you make a branch of the catalog, you make your changes, you merge those changes. In table versioning, you can do that at the table level. You can create a branch, make changes to the table, merge them in there. At the file level, using LakeFS, you can create a branch, make your changes to table, which would create changes on your file system, and then merge those changes when they're completed. Same thing for tagging and reproducibility. you can tag individual commits at different points in time and reproduce those. Okay, now when it comes to multi-table transactions, being able to do transactions across multiple tables and commit them at the same time to have that multi-table consistency, right now, you need to use catalog level versioning or file level versioning, because those will capture changes across multiple tables. Catalog because it's tracking those tables metadata references, and file level because it's capturing all the changes across all the files for all tables. All of them have the ability to roll back your data to a previous commit, whether you're rolling back the state of your catalog, rolling back the state of a table, rolling back the state of your files. And at the end of the day, again, you can use more than one of these. So sometimes having these multiple levers can sometimes create different opportunities for disaster recovery for different types of situations. Cloud agnostic. Okay, Iceberg and Nessie are going to be cloud agnostic. Okay, and so is going to be Lakehouse, long as the object storage is S3 compatible. Okay, so it just depends on the object storage solution of the particular cloud provider. Because Lakehouse is also open source and you can self-deploy it. And then there's, I think, also a managed service that you can get from the Treeverse company. It's the company behind that. Storage agnostic, again, for catalog and table versioning, it doesn't matter where the data is stored because it's not tracking the files and it doesn't depend on how the file system works. It's just a matter of how the metadata is tracked. So in that case, it's storage agnostic. For Lakehouse, for file versioning, it is dependent on the way the particular file storage mechanism works. So you would have to use some sort of S3 compatible storage layer. Table format agnostic. Catalog and table right now are not, because the only format that supports catalog and table versioning is Iceberg. Okay, one of the nice things about Iceberg that you have all three at your disposal. For Delta and Hoodie, really only file level versioning is available. So that's a thing. SQL operations. Okay, far as being able to use SQL to do things like make branches, tag, commit, merge branches. The Nessie catalogs have like full-throated SQL support for pretty much everything you can do with Nessie. So basically, there's no context switching, having to switch to like Python or Java in the middle of your transactions. Iceberg, for the most part, has SQL for most things. It's just for like that final like merge, you will have to kind of do some stuff with the Java or Python API to actually like bring a commit over, move with the different commits and cherry pick the different commits in Iceberg. And again, generally the way like FS works is you write your SQL, but the SQL doesn't look any different. It's just you're changing the file paths that the writing or reading occurs from to capture the different branches and make those different changes. So those are the difference between like sort of the three mechanisms for Lakehouse versioning. The beauty is that there is multiple mechanisms. It's beautiful that we live in a world where basically you can have a lakehouse that's going to have these versioning mechanisms that are actually more robust than what you would have just in a single data warehouse. And now data warehouses are being trying to connect to your data lakehouse data. So basically, these mechanisms allow you to really manage your consistency across all sorts of different tooling. Yeah, so it's a pretty exciting world. Again, my name is Alex Merced. You can follow me on Twitter at @AMDataLakehouse. And also, I recommend going to iTunes or Spotify to subscribe to any of these podcasts. And with that, let's begin the Q&A.
Great. Thanks, Alex. So let's start with the first question. This one actually comes from me. So you've talked a lot about Nessie as an open source data catalog. How does it compare to some of the other data source catalogs on the market? I know internally here at Anant, we talk about a Munson a lot. So how does Nessie compare to a Munson?
Well, I wouldn't honestly know that particular comparison off the top of my head. Specifically for, I mean, it depends on what feature sets matter. Again, a Munson's a platform I'm a little bit less familiar with, so I wouldn't necessarily be able to make that comparison off the top of my head. But it depends what your architecture is. Bottom line is if you're using Apache Iceberg. So like if Apache Iceberg is the table format you're using, the nice thing about Nessie is that it is one open source, so you don't have to you don't tie yourself to a vendor, and then later on, if you're not happy with that catalog vendor, you're completely have to change the context of how you do things. So for example, if you use a service that's based on Nessie, and then later on you rather just be on your own, you can switch that over, but you don't have to change how all your workflows mechanically work, because you can just basically it's still an open source platform. but the key things that like Nessie does for comparison to, so if you have in mind, like, so for those of you who are looking at other catalog platforms and trying to think, okay, hey, what is the comparison features to kind of keep in mind? Is like with Nessie, again, you can track particularly iceberg tables. You have the branching, the versioning that allows you to do multi-table rollbacks, transactions, multi-table tagging. So are you able to do that with another catalog? Basically, its governance features are growing, so you can actually govern each branch, and then each user can have like a unique token. So that basically, in that case, they can't necessarily read every branch. You can have protected branches. So there's security features, there's auditability because you can audit all those commits. So it has all those nice things. And I would say like all three options for Lakehouse version that we talked about today will have different levels. Well, particularly like well, basically within the catalog versioning, it has its own built-in sort of like security features. When you're taking a look at table level versioning, oftentimes the security, and the same thing with the file level versioning, the security is going to end up being more on the file system or on the catalog. So it's the catalog will end up being the sort of the barrier to unauthorized access, or the access to the individual files underneath the tables will become the barrier of access, depending on sort of like users' particular credentials. But trying to think of like other sort of catalog solutions. So like there's things like Unity catalog over there in Databricks, and very similar like set of features, but again more geared towards Delta Lake. Although they have recently introduced that whole like uniformat with Delta Lake 3.0, so you can kind of track Apache Iceberg tables on Unity catalog now, but it's more. I wouldn't say like if you want Apache Iceberg as a first class citizen in your Data Lakehouse, that's. But if it's like a secondary citizen, like if you're mainly Delta Lake, but you want to have some Iceberg exposure, that's when Unity catalog makes more sense. Just because what happens at the way the uniformat feature works in Delta Lake is that it writes the commits to Iceberg asynchronously and will only do so one time. So if like 5 transactions come into your Delta Lake table, it will batch those transactions and then write one commit to Iceberg. So you don't necessarily have the same full commit history as you would to your Delta Lake table. But you can, and then it exposes a REST API interface or a REST catalog interface to that table. The next question?
Yeah, interesting. Thank you. The next question is from Anne. She says, "Hi, Alex. Great presentation. Do you foresee a future where generative AI LLM may ingest a data lake and thereby enable a user to interact with it entirely with natural language access? Thanks."
It's already happening with Dremio, particularly with Dremio Cloud. There is now a generative AI feature. So you can, any transaction that you would run around on Dremio, you could literally just basically say, hey, I want to do a transaction with like these 2 or 3 tables, and then ask a natural language question, and it'll create the proper queries for you to do on any transaction. Because with Dremio, with Iceberg tables, you can do full DML. So I could theoretically choose the different data sources that I want, and then through data language and say, hey, I want to, take all data, all records from this table of a certain date, assuming that there's like a created at field in that table, and say, hey, I want to select and then insert those into this table, do that in natural language, and then using that feature in Dremio, it'll generate the SQL. You can just run it. So whether it's querying the data or even doing some light data engineering work for on the ingestion side, you can do that with Dremio with pure natural language now.
That's exciting. Thank you.
Super cool. I love playing with it.
All right, so we are close to the end of the session. We have a few housekeeping items to discuss. Thank you everyone for being here. But this is really close to the end of your window to ask questions. So please, if you have questions, ask them now. All right. So thank you everyone for being here. If you're watching asynchronously, please feel free to add questions to the chat. We'll try to get to them in time. And, we're just thrilled to be able to host this event. And Alex, thank you so much for this great presentation.
Thank you. See everyone next month.
Yeah, see you next month. All right, thank you everyone. And have a great rest of your